Welcome. Today class I'm going to look on moment generating function. Moment generating function or MGF. MGF is defined by mxt is equal to expectation of exponential tx. It's called generating function because at every point, every of its derivative at t is equal to 0. It can either generate mean or variance. Mxt can either be discrete, which is given by summation of all x exponential tx multiplied by its probability of the function given. And if it is continuous, it's given by integration from negative infinity to infinity exponential etx multiplied by function f of x dx. This if it is continuous case, and this is if it's discrete case. Let's look at one of the examples. We are given a function f of x is equal to 3 over 4 into 1 over 4 x, where x is equal to 0, 1, 2, as you continuous. 0 otherwise. So we asked to obtain MGF, which is MGF, and use it to find mean and variance. Let's start by finding the MGF. To find MGF, which will be mxt is equal to, because if you look at the function, it's countable, so meaning it is discrete, which will be, we are going to say it's summation etx multiplied by the function which is 3 over 4 into 1 over 4 x, but x starts from 0 to infinity. So we are going to factorize out the function containing x, which will be summation x is equal to 0 to infinity 3 over 4 into, it will be et over 4 raised to x. Because you are going to sum it from x 0 to infinity. 0 over 4 does not contain x, so it will be 3 over 4. We can write 3 over 4 outside summation. X starts from 0 to infinity exponential et over 4 raised to power x. And remember, it can either be 0, 1, 2 as you continue. So it will go into 3 over 4 into, if any number raised to 0 is 1, so it will be 1. You add et over 4 raised to 1. We add et over 4 raised to 2 as you continue. After writing that, we can let r be et over 4. After letting r to be et over 4, meaning it is going to be 3 over 4 into 1, we add r square as the process continues. As you can see, this function inside the bracket, it is a geometric series. And remember, geometric series, it's going to be 3 over 4 into 1 minus r, where r is less than 1, because it's geometric series. So it is going to be 3 over 4 into 1 over Remember, r is the same as et over 4. So it's going to be 1 minus et over 4. So if you do what with the denominator, it's going to look like 3 over 4 into 1 over LCM, which is 4 over, which is going to be 4 minus et. If you factor out, it's going to look like 3 over 4 into 4 over 4 minus et. 4 goes with 4, which is going to be 3, 4 minus et. Or we can say 3 into 4 minus et raised to negative 1. And so MGF is going to be the same as 3 into 4 minus et raised to negative 1. So we are finding MGF. So I asked to use MGF to find mean and variance. So let's look on how to find mean. So mean, we are going to look at the first derivative of MGF. So it's going to be the first derivative of MGF. So it will be d over dt. MGF was 3 into 4 minus et raised to negative 1. So we are going to use chain rule to differentiate. So it's going to be 3, you write the power, you find the derivative, what is inside the bracket, which will be negative et. Then you write what is inside the bracket, 4 minus et. Then you less the power by negative 1, which is going to be negative 2. If you factor out, it's going to be 3 et 4 minus et raised to negative 2. But remember, we said t should be 0. So it is going to be first derivative at t is equal to 0. It's going to be 3. Where t we put 0, which will be e raised to 0. 4 minus e raised to 0, negative 2. So it's going to look like 3, because any number raised to 0 is 1. So it will be 3. Here, 4 minus 1, which is 3. So it is going to be 3 squared, which is the same as 1 over 3. And this is going to be the mean. Mean is going to be 1 over 3. So let's look on variance. To find variance, we first find the second derivative of MGF at t is equal to 0. We subtract the first derivative at t is equal to 0, or mean, and a square. So first, let's look, because we already find the mean, let's find the second derivative. So second derivative is going to be d over dt. The function of second derivative is 3 et 4 minus et raised to negative 2. As you can see, there's two parts, this part and this part. Let's call the first part to be a, the second part to be b. So this part means we are going to use both chain rule and product rule. So first, let's hold the second part b and differentiate the first part. If you differentiate the first part a, it's going to remain 3 et. So the function will be 3 et 4 minus et raised to negative 2. We add. So we are going to hold the part a, which is 3 et. Then multiplying by part, we differentiate the second part. If we differentiate the second part, it's going to be right part the negative 2. Then the differentiation what is inside the bracket is going to be exponential negative t And we write what is inside the bracket, which is 4 minus et raised to, we less the power by 1, which is going to be negative 3. So, if we factor out, is going to be 3 et 4 minus et raised to negative 2 plus, if factor out, is going to be 6 e 2t 4 minus et raised to negative 3. So, remember it should be t at t is equal to 0. So, the second derivative at t is equal to 0 is going to look like 3 e raised to 0 4 minus e raised to 0 negative 2 plus 6 e raised to 0 4 minus e raised to 0 negative 3. So it's going to be if factor out is going to be 3 over 3 under square plus 6 over what's inside the bracket is going to be 3 square. So which is the same as 3 over 9 plus 6 over 27. 6 over 27, which is the same as 15 over 27. Or we can say 5 over 9. So variance is going to be second derivative, which is 5 over 9. And remember mean was 1 over 3. So it's going to be 1 over 3 under square, which is the same as 5 over 9 minus 1 over 9, which is going to be 4 over 9.